Okay, so the first thing I want to do is we want to take a look at the course outline or the syllabus. So you guys should have all found your syllabus was located here in the Start Here section. Hope that you found that. I do want to mention that the college is wanting us all to go to a similar format. So there's going to be a new syllabus that I'm going to be putting out there. But the one that you have is perfect because it gives us everything encapsulated. But I will be putting a new syllabus out there for you guys. So it's not going to change anything. It just has to do with the format that you'll see different. Okay. But let's go ahead. I'm going to open up the syllabus. We're going to take a look at that first. Okay. So you have a copy that you want to work along with that, you can. Maybe put some notes on here for you. So this is land information modeling, CET 255. This is the fall offering of this, and we usually only offer this one time a year. So this is what you're in. My name is Jim Decker. For those of you guys that don't know me, I am going to be your instructor for this. A little bit about me, I am a full-time instructor at the college. Been here for 30 plus years, professional surveyor, state of Ohio, have a civil degree from the University of Cincinnati. And like I said, I've been teaching this kind of stuff for a long, long time. So hopefully I'll be able to get you the kind of information that you need, and you'll probably see me in other classes. I know some of you are in my dendrology class that will be starting here on the 12th of September. So I will get to see you guys again in that one as well, and probably some other ones. Is anybody taking route location design right now? Yeah, okay. So you're gonna have that. That's also me. I'm teaching that as well. So
okay.
So a couple things. One is to know that I am available pretty much all the time. I'm going to be living either at my office here at home or at work, monitoring things. So you need to be aware that you can have access to me kind of whenever you need it. A couple of ways that you can get a hold of me. I have office hours, and it says that they're posted in the CIT office, but that they're actually posted at Starfish. And right now I have office hours on Mondays and Wednesdays from 8 o'clock in the morning until 1 in the afternoon. And I'll either be in my office here or in my office at work. So those are times that you can always talk to me. You can either contact me via email, there's my email, or you can contact me, there's my office line, the 513-569-1757. It is possible to meet with me face-to-face. You have to make an appointment through Starfish, and we would meet in room 210, and we have a couple of rooms that we will meet in. The college is kind of discouraging that face-to-face meeting, but look, I'm going to be there, so if anybody wants to take advantage of that, that's a possibility. The other method that we could do is we can schedule a Zoom conference. And I'm really big on that. I'm really a big proponent of Zoom right now. Zoom has worked really, really well. So you can certainly do a Zoom conference with me at any time, okay? So please keep in mind that if you have questions on anything concerning this class, any other classes that you're taking with me, that I will be available for help and consultation, okay? Sound good?
Okay.
All right. So the lecture, like I said, it's scheduled at 3. If we can just go ahead and we'll make this a schedule at 3:30. I'll change that on another syllabus, and that will really help me out because I gotta drive back and forth, and I was able to make that by 3:30 very easily. Okay, so that'll help. Usually, this stuff, like I said, this material is pretty straightforward. A lot of it's just right out of the book kind of thing. So we'll be discussing a lot of good stuff, but I don't think we'll ever go past 5:20. Okay, just so you know. The labs are going to occur on Thursdays. And they will be in room 223. They will not take that long to do. Some of them are very, very easy labs to do. Okay, so they will, you'll probably be out of there an hour, 2 hours max. And We can also discuss things further if there's questions. I usually will be giving you a quiz once a week. So that was usually when I will be doing the quiz, okay? I will also be using that Thursday lab time to do testing. So we'll talk about that here in a minute, okay? So we're scheduled for room 223, and we have to, of course, watch the social distancing issue, and you also are required to have masks on campus. So I just got out of a class right before this one that I was up on campus, and that's a face-to-face class, and we all had to do masks and the social distancing thing. So it works out okay. It's, you know, it's a little different, but it works. So just so we have it, okay? All right, so let's look at the grading for this class. So grading is based on 3 tests with different content. I'll go through that here in a bit. We have tests 1, 2, and 3. They're 20% each. We're going to have quizzes. They're simple quizzes just based on the preceding lecture chapter material. Those are 10%. And then the labs that we'll be doing and maybe some assignments. I have a couple of those that I'll also throw at you. Those are 30%, okay? So that was your total right there. The grading scale, pretty typical to what most colleges would use, I would imagine. 90 or above, 100, 80, 89, 70, 79. It is very easy to do well in this class, okay? I will tell you that up front. If you're attending lectures, you're doing the labs, you're doing the reading, you're gonna probably get an A or a B. The only way you would probably get below that is if you're not turning something in, missing quizzes, that kind of stuff, okay? So it really should be a really good class overview, but grading should be not a problem for anybody, okay? And also one thing, I always look at overall performance also. So, you know, if you're sitting at an 89 and you were there all the time and, you know, you're showing participation, you know, I'm gonna pop you over into an A as opposed to a B. So I'm not gonna look at strict numerics there. I always look at overall performance, okay? So some additional supplies that you might consider, we're not going to be really storing too much, but there's a couple of files and things that we might use. So you may want to have a flash drive or something that you could store stuff to if you need it. That would be helpful. A notebook or something to keep some notes in. Like I said, like a lot of people will just take those slides, print them out, and write information on those slides. That's helpful too. Just keep things organized. That's the only thing I would say. And we're gonna follow this book pretty, you know, chapter 1, 2, 3, and we basically do all the chapters in the book. So it's really easy to keep real organized with this. Okay. So some issues about success. You know, try to attend all classes. The one nice thing is since I'll be recording this, I'll record it and throw it up on YouTube. We'll have a link there for you. So if you do miss a lecture, that's not going to be real detrimental. All you need to do is just key in like later in the evening or probably by Wednesday, I'll have that up there for you. And it'll be in the same folder that the week occurred. So this lecture will be in week 1 folder and next one week 2 and that kind of stuff. So I'll make a habit of doing that because I do have a couple of guys that are going to be doing this remotely. Try to actively learn from your lab assignments and also, you know, read the book because this book is actually really decent book. It's good material. It's really an eye-opener. There's a lot of things to it that you may or may not be aware of. So that's also good. So some policies in the class. It says that failure to take a test or a quiz on the indicated date will result in a 0. So basically, I've got dates scheduled for tests, and I know that everybody has something going on at certain times. So I'm not saying that you're going to get a 0 if you just don't make the test. What I'm saying is if you just don't show up and inform me, it'll be a problem. I will certainly work with anybody's schedule on that, and so we can work that out. I just need to know up front. Let's say, hey, you're going to miss a day, whatever, and we'll make that happen. Okay. Making up labs is going to be not an undoable thing, but it'll force you to like maybe do 2 labs in 1 week. So if you miss, let's say, lab 2 and you come in on 3, we can probably knock out both in one time. Just make sure that you do them all though, because the labs, like I said, are 30% of the grade. So we want to make sure that you do all of the labs, okay?
Mr. Decker,
Yes.
are the labs based on AutoCAD, or are we using any software for the labs? What's the labs consist of?
A good question, and we're going to get to that, but the labs are not based on any one software, Greg. They are going to be based on all different types of softwares. So we're going to be utilizing a lot of different little things. We will be using, I think, Civil 3D for a couple labs at the end. But so I'm going to the book kind of goes all over the place. It's kind of neat. So I'll get to that here in a sec, okay? All of the software, by the way, that this book uses is completely free and downloadable, and most of it's really simple stuff. So you can actually download it yourself, okay? Does that answer your question?
Yes.
Okay, cool. All right. So there are other labs at the college that have this software, but because the college is kind of locked down, we're going to probably be limited to 223. So I'm not going to say that all these other rooms are even open, but we will be in room 223. Okay. So just kind of focusing on that. And we will do the labs at 3 o'clock instead of 3:30. So I'm just going to move the lecture to 3:30. We'll do the labs at 3. That way you guys can get in there, get out of there, and hopefully get done quickly, okay? So there's some resources that are available for you, some good stuff that comes out of this whole concept. One would be Environmental Systems Research Institute, usually pronounced ESRI. These guys are these are the AutoCAD people of the GIS world. They have probably the worldwide market share of GIS software, and I got to go test this out tomorrow. But we have the GIS software on campus. That would be the only one that's hard for you guys to get because it's expensive. They do have a 30-day trial, but you really won't need to download any of that stuff. But you might check some of them out, these guys out, because they have some good GIS information in general. If you're not aware of this magazine, XYHT, it's an awesome magazine. This is probably of the 3 major surveying magazines out there, it's my favorite. It actually has just great content. If you don't have a subscription to it, you should get a subscription to it. You can just go out to these guys right now, and it's a free subscription for people in the industry. So I would highly, highly, highly suggest it. The other one is Point of Beginning magazine. They just recently went to a online or a digital format completely, so they no longer publish a magazine, and they're also going to charge you. They didn't used to charge you, so right now I'm not currently getting that magazine because I didn't want to pony up the money for it yet. I probably will at some point, but they're also a good surveying magazine, and the other one is American Surveyor. And probably of all of these, the American Surveyor and XYHT, these are actually awesome resources. So if you guys are not subscribed to these magazines, I definitely suggest that you do all 3 of them. And POV, like I said, they're going to charge you right now, I think now, but the other 2 don't currently. Okay, so check those guys out, and like I said, I'll be sending you articles to read periodically from them. So, all right, special needs. We have disability counselors at the college that anybody that needs a little extra time testing and that kind of stuff can work through disabilities, and they'll work with me. Just make sure you go and sign up or talk to somebody with disabilities before you get into your testing and that kind of stuff, because I have to sign a form, and all of that has to be worked out through them. Okay? All right, so let's take a look at the next page. This is, well, let me see. Any questions on this before we move on? This is just kind of the basics. Okay, I'll take that as a no. All right. This is the kind of the roadmap to what we're going to be doing over the next 16 weeks. And you'll notice that I've got this down by the week. I don't have the date on this, just the week. The area of concentration that we're going to be talking about, lecture topic, and then the chapters that we're going to be doing. And you can notice one thing is we're going to be buzzing through this entire book with exception. I actually might change a few things around at the end of this, but we basically skipped chapter 12 and 14 and 15. So we pretty much do the whole thing. It's kind of broken down into three major areas. The first 4 weeks kind of deal with what's just called geospatial data in general. So we're going to kind of be talking about that. And then that'll bring us up to our first test, okay? So we won't do much this week. I can do a review on that 5th week, but I'll primarily just looking at doing the test. That'll be on our Thursday, okay? And so you guys that are doing that remotely, I'll work that out with those guys when we get to that point, okay? Then you're going to get into geographic information systems, or what is typically called GIS. We're going to work a couple of weeks doing this, and you can notice there's 4 weeks of GIS dealing with the particular lectures. Okay, so that'll be chapters 5, 6, 7, and 8. And I do enhance a little bit more in here what the author does. So we talk quite a bit in here. This will probably be the newest thing for most of you guys. I'm not so sure how many people. Is anybody using GIS much at all, or any?
Yes, I do.
You do? Okay.
Yeah.
I use it.
I do a little bit.
Yeah, and most people like view it kind of thing, but they don't do any analysis with it, that kind of stuff, which we're not going to do much in depth, but we are going to talk a lot about just the overall landscape of how it works and that kind of stuff. So, you know, we're not going to do...
We generally use GIS to supplement our topographic base maps, but
Okay.
That's about it.
Okay, cool. Well, we're going to be talking about other things that'll be a little bit different. So hopefully that'll be a really good aspect in the GIS for you guys. This course, by the way, actually kind of morphed out of a GIS class. At one time, this was a 10-week GIS class, and it was kind of hard to teach actually back then at the time. And so we kind of morphed this, and I think this is a little bit better. Although my thinking is kind of reversing. I might think at some point we may want to go a little bit heavier in GIS, but for the present time, that's what we're dealing with. So I forgot to mention, the first test is based on just the first 4 weeks of material here, okay? So when you get to the next 4 weeks here, then this second test is just based on GIS specifically. So you're not gonna have information on test 2 that's dealing with chapter 1 kind of stuff, okay? So they're all separate and distinct in what you're getting into. The last section deals with remote sensing and some geospatial application stuff. And so you can see what we're going to be getting into there. And then the last test we'll be dealing with is this test 3, and that'll be dealing with this area right in here, the remote sensing and that kind of stuff. Okay. We do have a Thanksgiving break in there. I think the break actually starts on a Wednesday, but we'll probably won't do anything on that Tuesday. What I might do is open that up for people that maybe want to, if they're missing a lab or something, maybe I can meet you over at the lab and we can make up a lab or something. So that might be a good way of doing that. Okay. So we'll take a look at that. So we should be following this pretty verbatim. I don't think that there's going to be any changes. Definitely not. In terms of the testing, that shouldn't change at all. And content, I might change some things up down here. We'll see as that comes along. Okay. If I do, I'll let you know. All right, so the next page is showing you what we're going to be getting into. And Greg, this kind of shows you the question that you asked me about the software, what we're going to be utilizing. We're going to be dealing with a lot of little different things. So for the first week, where we're doing our first section where we're dealing with geospatial data, we're going to be using Google Earth. For the first 2, this little program called Map Cruncher, which is actually a really cool little thing. It'll rectify scanned images for you and basically bring them down into a georeferenced framework. That's kind of a neat thing. We're going to use the Trimble planning software a little bit. We talk about the GPS applications. We're going to talk a little bit about GPS, but not much. So that's a pretty basic overview on it. When we get into the geographic information system stuff, we're going to be using this program called ArcMap. So that's kind of like the industry standard of what people are using out there right now in the GIS world. they do have a new program that just came out a couple of years ago. It's called ArcMap Pro, or just Arc Pro. And Pro is kind of going to start to displace this. So if you are an ArcMap user, at some point you're probably going to be migrated to this. My understanding is, I have a friend that I teach another class with, and she teaches the GIS portion with me, that Esri dumped this Pro out on people, and people absolutely hate it, the users. So they've kind of backed off on that. So they're probably going to, they were going to get rid of ArcMap like this year or next year, but I think they backed off on that because Pro hasn't worked out for them the way they wanted it to. But eventually this program will go away, and the new one will supersede it. Now, if you don't have access to ArcMap, and if you're working remote, there's another one called QGIS, I believe. That's a free one. So essentially, you can either use ArcMap or QGIS. So we'll talk a lot about that as we get to that point. When we get into the remote sensing stuff, we're going to look at Google Earth again, and then we're going to look at this one called Multispec. And so this is a really neat little satellite imaging program that we will take a look at. And then, again, that's a freeware. I think that was written by some guys at Purdue University, and it's a remote sensing software, which is, if you've ever seen that commercially, that stuff's really, really expensive. But this is just a little thing that we use. And then we'll talk about some digital terrain analysis stuff. So we're gonna introduce or get into Civil 3D a little bit. Okay, so we'll just kind of play with some of those. So you're getting introduced to some new little softwares. The big piece of this is kind of the ArcMap stuff. That's kind of an eye-opener for people that haven't used any GIS software at all. And we'll be looking at it more from an analysis standpoint, but it's really, really simple, small data sets. So none of this stuff is big. It's just to kind of show you an overview. Okay, so that would be what we're looking at there. So that is the course outline. Okay, like I said, I have a new course outline that's coming out. It actually is the same. All this information is the same. The only thing it'll change, I'll change the time on my Tuesday. And the other thing I will do is it's going to have more information for student services, things like withdrawing from classes and COVID information, that kind of stuff. Okay. So does anybody have any questions on any of this?
No.
No, sir.
We're good?
No.
Okay, perfect. All right, so keep this, like I said, if you haven't printed this out, I would probably go ahead and print this out. Kind of keep it, just have it. You'll kind of know what's going on. If you miss a week or something, you'll know exactly what's going on here. And that'll I think, help you to focus in. I might also, I haven't done that on back here, but I might, under the weeks, put a little bit more detail in terms of what we're reading, assignments and stuff like that. So I might start adding some of that as well. So that way, if you miss a lecture, whatever, you'll have the stuff out there, but you'll also have what we're expected to read and that kind of stuff. Okay. So with that, let me go ahead. I'm going to go ahead and open up my PowerPoint, and we're going to go ahead and get started with the official lecture part of this. And what we're going to be looking at is chapter 1. Anybody not have their book yet? And somebody emailed me that they were not going to have their book yet. Does everybody have a copy?
I'm still waiting for mine to come in.
Okay.
I'm still waiting for mine to come in. It's on the way.
Okay. It's not going to be a problem. I think everything you're going to get out of this today will be fine. Hopefully, though, you'll get it by next week. Okay. But again, the labs are actually going to be right out of this book as well. So for the lab portion, and I figured that I'm going to be running copies of that for people. So if you don't have your book, I'll bring the information with me for the lab portion, because you kind of follow it step by step. Okay, so that won't be a problem. And as soon as you get it, then you'll probably want to follow up the reading on that. Okay. All right, let's go ahead. I'm going to go ahead and get this started. And start it from the beginning. So let's see. All right, so what we've talked about was the course outline. And I'm going to look at the lecture organization with you, and then we're going to look at this. We kind of already looked at this. And then what lecture 1 is going to entail, your author titles it, it's a geospatial world out there. So one thing about this author that you need to understand, he is not a surveyor. I believe he's a geographer. So his take on certain things is going to be a little different than ours would be. But I think you're going to see there's a lot of good parallels here. And he does go into some things a little differently than we might. And I'll try to point that stuff out. But in general, I think he's written a really good overview book. The other thing about the book, when you do get a copy of it and you get a chance to look at it, besides the actual text itself, he has little boxes on the sides of the margins very often with, like, say, a defined word. That's a really good thing. So he'll usually bold the word in the print, and then over on the side, he'll have a definition of it. So those are really, really good things to kind of key in on. And the other thing he's done in here, which I really like, are what he calls hands-on applications. And they're usually a purple box. And then he'll have like, okay, you might try looking at this, go to this web page kind of thing. And then there's some things, and then he's got some expansion questions for you to think about. There's some really good stuff in there. So when you get that, kind of take a look at that, okay? Because you'll see what I mean. And anybody that has the book knows what I'm talking about right now. And at the end of each chapter, then is when you get into the lab material, and that's what we'll be running through. So like I said, for Thursday, I'll go ahead and run copies of that, and I'll probably go ahead and post it also out online, because I'm not sure how many people are going to need that. The guys that are going to be doing that remotely with me, okay? So I'll make sure that everybody has that, okay? So the first lecture, he kind of breaks it down. We're going to talk about what geospatial data is, that kind of stuff, and we're going to talk a little bit about geospatial technology today, who uses this type of thing, what we mean really by geospatial data, how is this related, or what does it have to do with geography, and what do we talk about by the concept of geolocation, and then we're going to look at Google Earth a little bit, and that's what the lab is going to be entailed. So this lecture goes pretty quick, goes pretty easy. Okay, so the course outline we just gone through. So here's the lecture organization. What we're going to be doing is the first week, geospatial world out there. It's going to be a basic concept kind of class, overview of the technology. So like I said, this one's will be pretty easy. So chapter 2 is a really good chapter. This was kind of like it's kind of like a control surveying, little bit of an overview. So if you guys have had the control surveying class or you deal with that, this deals a lot with coordinate measurement. We're going to talk about geoids and all those kind of things. So this is a great place to introduce that if you haven't had that. And it also talks about 3D to 2D translation, those kind of things. So we'll be talking about that next week. Third week, you're talking about getting your data to match a map. This is a process of what they call georeferencing, where you're taking information that doesn't have any actual ground location and you're bringing it down to the ground. That's a process that we call georeferencing. And a lot of times as surveyors, we do that all the time, but a lot of times we just kind of guesstimate a coordinate or just use a coordinate 1,000, 1,000. So we don't really georeference something based on that. So it's a different way of looking at it. We'll also talk about a process of reprojection. So in 4 deals with GPS. It's just a simple overview for the GPS. You guys that are using GPS, you'll know all of this stuff. Most of you probably do. But I'm just going to run through it. He talks a little bit about origins, position measurement errors, and applications. I usually enhance that with stuff that I have, because your author, like I said, he's not a surveyor, so he's not going to have as much information. And anytime I can enhance that kind of stuff, I will. So that'll be the first section. That would take us through to that first test. Then we get into chapter 5, 6, 7, and 8. This is where we begin to get into the GIS portion. So the first chapter is working with digital spatial data in GIS, introduction to that, and creation and use of GIS data. Okay. So a lot of you guys indicated that you're using GIS data, but there's going to be hopefully a lot of things about it that you're not aware of. So particularly terminology, and that'll be a big piece of it. 6 is using GIS for spatial analysis. So this is where some of you probably have never used this before. And so we'll talk about what we call database querying and also the process of what they call geoprocessing. So these are two big areas when we get into GIS. Using GIS to make a map, you can do a thing called what they classification, which is actually a really cool process, and the map creation. And this is really, really interesting stuff too. And again, that's where GIS has its strong suit, is being able to make maps. And then the other thing they're going to talk about, the last topic we'll talk about, is navigation and what we call shortest paths and networks. So that's another issue that we'll get into with GIS. Unfortunately, he doesn't actually do anything with GIS in terms of the shortest path, the networking. That actually is very involved. We'll talk about the concepts of it, but I don't think the lab actually deals with that. So after we get through that section, and that'll be our second test, and then we get into the remote sensing aspect. So 9 and 10 deal with remote sensing. What it starts out with is it talks about remote sensing images. So we're talking about the process of what they call photogrammetry. So chapter 9 deals with photogrammetry. And that's, again, a very interesting topic. I think, again, some of you might be involved with this a little bit more, some people less. But again, a lot of good terminology and processes that we'll talk about here. And then when we get into 10, we're going to talk about more like satellite remote sensing. So this will be a little bit different process. So what's going on here in chapter 10 is different than what we're looking at when we get into chapter 9. Okay. Chapter 11 deals with more satellite imaging and remote sensing. We'll talk about LiDAR a little bit. And I might try to bring in some other information when we talk about this. So again, I might change some of this up a little bit. And then the last chapter we're going to look at is 13, which he calls it digital landscaping. And I would pretty much call it 3D modeling, where we're talking about terrain modeling or terrain visualization. And both of these things are really, really big, of course, if you're dealing anything with like highway design, where you're doing machine control work or anything, and even doing certain design, you know, the terrain modeling and visualization is a big piece of it now. So in fact, companies are actually starting to expect that quite a bit. So again, so we're touching on a lot. Once we get into this will be the last, that'll take us to the last sequence of stuff that we'll get into, and we'll do that last test. Okay, so the geospatial lab applications, you're basically going to cover one aspect of geospatial technology at a time. We're going to use that freely available software. The ArcGIS ArcMap, that is not free. Okay, so if you wanted to play with that a little bit, there's two ways you could do that. One, you can download a free copy. It's a 30-day trial. Okay, so what you might want to do, if you decided you wanted to do that, I would wait until we get into that 6th week. So that way you would pretty much have it the whole time that we're using it at work, or at you know, for the sections. If you go out and download it now, it'll probably expire before we'll even get to that point. So, and the other way, if you're interested in using ArcMap, they have what's called a home edition available. Esri does, and I've actually done this for a couple of years. I think it's $100 that allows you to download everything that they have, but basically you only get that for a year. So it's kind of like you lease it for a year, but every piece of software that ESR makes, you can download. So again, if you've got a little bit extra money that you want to do that with, it's cool, but it expires in a year's time. So if you want to re-up it, you have to do $100 every year. So I've done it myself. I've since let my lease lapse because I haven't been using it as much. But again, it's kind of a cool thing to do. Google Earth, Map Cruncher, the planning software, Multispec, these are all free. There is, by the way, I guess I should mention this, and he talks about it in the book, there is a program called QGIS which is free and available for download. And QGIS is actually software that's just as powerful or becoming just as powerful as ArcGIS. But it's completely free, and there's a big user base that is involved in that right now. So that's something that some of you guys might consider as well. Okay. All right. So the labs. Okay, this is the labs that we're gonna be dealing with, and we'll get to more of these. But notice in 1 we'll be doing Google Earth, 2 Google Earth, 3 was that Map Cruncher. That's a neat little guy, and that actually I think is a Microsoft product. I think it was written by another group, and Microsoft kind of took it under their wing. So I'm not sure I don't think even do anything with it, but it's actually kind of neat. We have the Trimble, ArcMap, Google Earth, and then that's multi-spec and ultimately Civil 3D. All right, so that's what we're looking at. Okay, so if no questions, then what we're going to do is get into chapter 1, and I will try to cover this as in-depth for you as I can. I think a lot of you guys are going to know a lot of this stuff already. But I do think the one thing about it, it's very good terminology. If nothing else, it takes kind of what we do as surveyors, and it takes it from a different point of view. So it's interesting to say how a geographer thinks, or somebody that's related to our field, but not quite in our field, looks at some of these issues, okay? So we'll talk about what it is, who uses it, kind of what geospatial data is, geography, geolocation, and Google Earth. Okay, so one of the things, and I'm sure everybody can answer yes to these questions. If you've ever done any of the following, say you've used an online map service, and I'm sure everybody has, I've used those, in-car navigation system, or which could be your cell phone now, a GPS receiver kind of thing, or an online database. Basically, you've used some kind of geospatial technology, okay? And like we being surveying people, we're probably the consummate geospatial people out there, as opposed to some of the things that he's going to call geospatial applications or geospatial things. Surveyors, by and large, I mean, that's what we do. That's our business. So everybody has done this from this regards, and even people that weren't involved in surveying have done this kind of stuff. So geospatial technology would be any kind of technology that is using information to assist it. So things like mapping, location, direction, imagery, analysis. So we could definitely say, as a surveying group of people, mapping is a big part of what we do. Let me go back. So not only creating maps, but using maps. We've been on the forefront of that forever. Certainly, we can all say location, and location can mean a lot of different things. For instance, location can really fall under kind of 2 categories. You could do a 2D horizontal location. You could do a vertical location in terms of elevation, or you could do a truly 3-dimensional XYZ kind of thing. So it just depends on what we're doing. But again, we do that all the time as a surveying group. Direction, of course, bearing, azimuth, those kind of things, turning angles, we certainly get into that. Now, where we might fall short on some of this that other people deal with in this terms would be imagery. So what we're probably talking about there are the 2 types or classifications of imagery. One would be photogrammetry. Is anybody working with UAVs right now? Anybody working with a UAV?
No.
Everybody know what we mean by that?
Yeah.
Okay, so we're talking drones, right? So they're using primarily a photogrammetry format, taking pictures, but also some of the UAVs are now using LiDAR. So those are usually a little bit more expensive, higher level type UAVs. So imagery could be, it could be satellite imagery, it could be LiDAR, it could be photogrammetry. So we're probably, I mean, I think surveying, our group is getting more and more involved in that, but some people probably aren't using that as much as others. And the analysis, depending on what you're doing, obviously we do a lot of analysis, okay? So geospatial technology would be anything that is technology-assisted information concerning these things, not necessarily all of them, right? Okay, so we can think of a geospatial technology that uses a high-tech system that will do these things. And we can think that it acquires data, it analyzes data, manage data, store data, and visualize data. And so primarily, actually, if you ever look at the definition of GIS, that's the definition of GIS right there. An information system that acquires, analyzes, manages, stores, and visualizes. But what we're talking about here, just geospatial technology in general, it's just high-tech systems that do these kind of things. Now, they don't necessarily do all of those things, okay? But they're gonna probably do 2 or 3 of those things. And in general, you're talking about location-based data, okay? That's an important distinction to make because there is another type of data out there that is not location-based, and we use both types. Does anybody know another term for location-based data? Nobody? Another term for location-based data is spatial data, okay? So you're gonna hear that term very often and quite a bit as we get into particularly GIS, okay, particularly that aspect. Non-location-based data, as we'll talk about, is also referred to as attribute data. Okay, and I'll give you examples of both of those things here. Okay, so geospatial technology has several major disciplines and techniques that are used out there. Primary one is probably now this guy, the Geographic Information System. That is probably the driver for all of this in this world. And in fact, GIS impacts you guys probably a lot more than you know right now. The other thing about GIS that a lot of people don't realize is that it has been around a long time. A lot of people get the idea that, well, it's a fairly new technology. It actually predates things like CAD systems. So it goes back to the 60s, actually, maybe even started probably in the early 50s, mid 50s. So geographic information systems have been around a long time. Remote sensing, either what we're talking about there would be aerial photography, satellite imagery. You could probably classify LiDAR as that as well, because that's also done from a remote concept. That's been around a long time as well. So these are big things in the forefront of geospatial technology right now. And of course, global positioning systems, which has also been around since the really late 70s when they really started it, but it's really came on board in the 80s and 90s. So we've had this for quite a bit, and really changing the definition of how things are going to happen, particularly with control. That's going to be morphing and changing quite a bit here, and it's going to be all based on GPS data. And we'll have a lot more to say about that in the second week, next week. Okay. All right. So, who uses geospatial technology? So, pretty much everybody does, whether they know it or not. But there's a wide variety of fields, and it's very interesting to see some of these because we notice that you may not think that some of them are involved in this, but definitely we see that. And one of the ones we don't have there is surveying, but really we know that because we're surveyors, but some of the things that we do see is government use of geospatial technology. We'll talk about some of these. Law enforcement, public health, which is really kind of a critical thing going on right now with the COVID process going on. Forestry, biology, environmental studies, agriculture. Agriculture is really, really big in some of this right now. It's pretty amazing what they're doing, as we'll talk about. And forestry, believe it or not, this was one of the groups, forestry is one of the groups that actually drove the whole GIS process. They were early adopters and users of GIS long before government got involved with it or anything else. So some of these guys have been using this technology for a long, long time. So this is showing pictures a little bit about some of the different things, and you can see what we're probably relating to, but very interesting. This is like your what they call precision agriculture, and these guys have really taken on this geospatial technology kind of stuff by storm. You can see this is probably some kind of stuff going on, like looks like after a fire. This is probably some kind of thing dealing with maybe law enforcement. Of course, those are classic GPS types of pictures. All right, so let's take a look at archaeology. This is kind of a group that has really embraced this. And at one time, if you've ever seen how they did archaeology, they used to lay out grids literally with strings that were like, 1 meter by 1 meter grid kind of thing. And they would identify locations of artifacts based on, where it was within that grid. And then they would measure down from the grid. So it was very laborious for those. Once they figured out that there was a thing called a tittle station out there, archaeologists started using it quite widely. And now they've really adopted the LiDAR technologies and scanning. So that's become a big thing. But the one thing about archaeology is, and when you study archaeology, you have to pinpoint the location, the artifact directly in XYZ space. And the Z is very critical because that's the depth at which something occurs. And so that gives them a time frame, a time issue, and how they do that. And it gives them the ability to construct site maps, and then you can search for patterns. One of the big things that archaeology, a lot of you guys might not be aware of, but they have tied this into tree ring analysis that's called dendrochronology. And dendrochronology allows you to determine exact dates on things based on tree rings. So, like for instance, out west where they'll find archaeological sites of the Anasazi Indians, Native Americans, they built a lot of their structures with mud, but they also use these trees that they would find, would cut, and they can count the tree rings and determine exact time periods, exact dates. So this stuff has really, really exploded. And so, like I said, archaeology, they use it quite a bit as a technology. So this is an example of a map, probably a USGS or a GIS type of map from the National Park Service, and they're showing you types of pipes that they found in the time period that they were found, and the overall distribution. Okay, city planning. Planners are big proponents of this technology. Planners are actually some of the ones that have embraced and used GIS a lot, probably more than a lot of the other groups. And in fact, if you take a planning degree, like you get a master's or something in planning, a big part of that will be GIS because these guys utilize that extensively. But they'll use these things for like coordinations and planning for purposes of things like utilities, traffic management, traffic handling, zoning, housing. So this is a very big portion. And of course, managing and updating records. So that doesn't just apply to city planning, obviously. Of course, we get into that with records that we look up for deeds and those kind of things. So all of that would be falling under that category. Environmental monitoring. We look at a lot of different things in environmental monitoring, and land use change over time is a big piece of that. So we are starting to see a lot of things happen on this earth based on that. And one of the things that they've got now, because they have Landsat images that go back years now to the 70s, and they've been tracking things like how much we're losing in deforestation due to either forest fires or primarily agriculture, those kind of things. They can track that directly. We're looking at things like pollution tracking and air quality. These are also particularly good things of information. Water quality, and one of the big areas driving a lot of things now is this global temperature change concept. So this is all due to that. And again, geospatial technology, GIS, they're using that quite a bit. If we look at a map here, this is showing you, it might be hard for you guys to see, but you notice this is the amount of carbon monoxide concentrations. And you might be able to not see it in this outline, but it's there. You notice this is South America, and this is the African continent. So you notice the red is higher concentrations of carbon monoxide, and you can see that's in the spring. But notice where a lot of this is. Anybody know why you think that's going on over in this region right here? Have an idea? Or if we look down here, we notice what's going on. There's a lot of carbon monoxide happening down here. Anybody know what's happening in these regions right here? What those are? This is South America, and this is the African continent. Anybody suggestion?
Oil related?
Or burning something.
Yeah, it's actually burning, right? And what we're looking at, where those blobs of red are right there, those are where this is where the equator is coming through. And so primarily what we're looking at, this is the rainforest. And the rainforests are being extensively burned right now in these areas. And what that's doing is releasing huge amounts of carbon and carbon monoxide. And primarily it's being done for what they call slash and burn agriculture. It's kind of a worrisome thing because the rainforests are considered what they call the lungs of the earth. And so a lot of oxygen is produced here. Also, a lot of water that gets out into the atmosphere is produced here. So when you hear about the deforestation that's going on in the rainforest, it's a really worrisome thing for those kind of reasons, but also because a lot of the biodiversity of the earth is actually centered right in these areas. So you have species in these areas that exist nowhere else, and they exist in limited ranges. Just to give you kind of an example so that you get the idea of species diversity, when you come up into, like, say, the temperate world out here, you may have, let's say, in the state of Ohio, you may have 50 trees, right? 50 different tree species. In 1 acre of rainforest, you may have 200 species of trees that are completely different. So just to give you an idea that the diversity of what's going on down here is incredible. And when you see stuff like this and you can monitor it, it puts all of this in perspective. So this thing's constantly going on. So forestry has been big on utilizing geospatial technology. Like I said, they were probably some of the first. One of the first major GISs occurred in North America up in Canada, and it was based on kind of the extractive industries, forestry being one of them, and other natural resources, like somebody mentioned oil, gas, those kind of things. Those were part of it as well. But forestry has used that, and they use that for modeling habitat, forest fragmentation, and really fire management and assessment. So fire management right now is a huge thing, because you guys are probably all aware of the fact that what's going on right now in California, we've got major fires going on right now. And I was just recently out in Yellowstone National Park, and I was back in August, and it was pretty dry there. It's usually pretty dry in certain areas, but now they have I just read yesterday, a 300-acre forest fire going on, and so that kind of stuff is a big thing. One of the things that's happened, you guys may or may not be aware of this, but with forestry adopted in the early part of the 1900s the concept of putting fires out. And so for many, many years, up into the 50s, it was all about fighting fires and not letting fires happen. And that trend has completely reversed because they found out that forests actually need to burn. That's how they regenerate. Certain tree species, they can't even reproduce, or well, they can reproduce, but their seeds will not, they will not grow without a burn. And back in the, I think it was in the 70s, Yellowstone was just full of dead trees, and they had a fire that swept through it and almost burned a lot of the forest down. But it was really due to the fact that we were managing it improperly. So now we're paying for that. We see these fires out in California and that kind of stuff. That's not the only thing that's causing it, but that's part of it. And so now they're managing it. They're doing, some of you guys may have heard of the process of prescribed burns. So what they do now in a lot of areas is they actually go in and burn areas on purpose in periodic time frames. The other thing we're seeing with forests is things like insects that will sweep through a forest. Like you have in out west, you have what's called the western pine beetle that will come through, basically destroy the forest, and then after that will come a fire. We have a southern pine beetle also. If you guys, anybody's ever been down to the Red River Gorge area, you'll see a lot of beetle kill down there on some of the trees. And so these are natural occurrences, and foresters track this kind of stuff through habitat modeling, that kind of stuff. Okay, this is showing you a Virginia Department of Forestry wildfire risk assessment kind of thing. Homeland Security. Homeland Security deals with risk assessment, kind of things like evacuation plans, smoke plume modeling. We're seeing right now evacuation that's probably going on down in the Gulf Coast because we have the two tropical storms that are coming in and hitting. And that's an unprecedented thing. I think this was, I just heard on the news that that's one of those things that hasn't happened ever, that they've recorded, where you have one tropical storm right on the heels of the other. So it's going to tend to probably dump a lot of rain. I haven't heard anything about it today yet, but they're looking around the Louisiana coast and Texas at being a lot. So Homeland Security is involved in that. You can certainly see how geospatial technology would be a big help in this area, particularly with mapping technology. Pretty much always when you get into these kind of things like these major fires that are going on and whatever, you will almost always see ESRI be part of that. They will send people out there and develop the maps and deal with the GIS aspect of it. So that's always something to kind of keep an eye on. Law enforcement. Law enforcement has been starting to utilize this more and more and more. One of the things they've figured out is they can do like crime analysis patterns, areas that are getting certain types of crimes periodically or throughout, and they can kind of pinpoint where these things are occurring, and then determining patterns, determining where potential new crimes may happen. And they also can gather high resolution aerial surveillance data now and add that into this. So again, these guys are starting to tap into this. This is an interesting map showing you, this is from Minneapolis police from some years ago. This is 2011. But each of these is showing you this little, you see things like homicide and rape and robbery. And you notice like some of these, they tend to happen in clusters. And so they can look at those clusters and analyze what's going on. And of course, Minneapolis was caught up in all of the stuff that was going on in summer due to the shooting up there. So it's a very changing dynamic, but this stuff is really, really being useful for these guys. Public health. So now we're seeing this right now with the COVID aspect, but been big on monitoring disease and tracking sources. And of course, you're mapping health-related issues. You can't hardly turn on the news anymore and look at the maps that you're seeing out there due to the COVID issues. And like, for instance, Ohio, governor was on today, and they always show the map with the different counties and, what level of COVID exposure they are dealing with at this point. And you have both public health, you'll have local level public health, you'll have state level, and you have national level. So those are all kinds of things. And guarantee you, you know, we talk about this as being a pandemic and it's a once in 100-year kind of thing, but you know, these kind of things do happen quite often. I mean, the last one we really had was the Spanish flu that occurred in the 1918s. It killed a lot of people. So we're going to be seeing this over and over, I think. And here's an example. The CDC puts this map out every year when it has to do with the flu. And of course, now they're talking about, probably you guys have been following this as well, that the worry is now that with the flu season coming on and the COVID kind of thing, how those things are it could potentially get worse based on that. But again, the geospatial technology, you can see how this can be a big thing that will make this work. Real estate, and this is interesting, real estate has really taken this on. You guys are probably aware of that because you guys probably work with a lot of real estate people or real estate related issues. But the real estate area has started to generate and create maps. You can then do things like compare housing prices and values, examine property features such as topography, or you might be proximity to things, how close you are to a certain school district, floodplain, selected features that you might want to be looking for. Anybody used Zillow or seen Zillow before? Anybody familiar with that?
Yes.
Great tool, right? It's a great tool if you're.
Yeah, lots of information in a small
Absolutely.
space. Yeah.
Absolutely. And so, you know, anybody now can do that. I mean, it used to be where you would need a real estate agent to do a lot of this. This really cuts out a lot of those people. And it's just feeding from all these different databases, it feeds that in. And it's, you know, it's free, open to the public, and available to you as a user. So these are all really, really good things. Okay, so let's take a look at what we specifically mean by geospatial data. So geospatial data really falls under two broad classifications. What we call spatial data, and then we have non-spatial data. So when we talk about spatial data, it's primarily location-based type of data, okay? So a coordinate would be location-based, or a length, those kind of things. It is the basis for all geospatial technology applications. So really, it doesn't work without it, geospatial technologies. So somebody has to provide that. And that's the big piece sometimes. And of course, who's providing that is very often our group, surveyors. But of course, it can also come from other sources now. So it could be coming from photogrammetrists. It could be coming from remote sensing, all right? But what you can truly say about geospatial data is that it knows where something is located, okay? So we know where something is located. Now, we also can talk about a concept of spatial dimension when we talk about spatial data. So spatial dimension comes in one of four types of things, typically. We talk about point location. Another name for that is what they call a zero-dimensional object. So in the concept of GIS, they usually use the term point, but they also think of it as what we call zero-dimensional. So that means it has a location in space, but it doesn't have a length or width or anything like that. So it's got a zero dimension. Length is, whoops, let's go back. Length is a one-dimensional object. So it has a length, doesn't have a width. So associated with the length, of course, for us in surveying, we would also have a direction. So when we think of length, we're also really, it's not saying it here, but we're also thinking direction. But we consider it a one, they call it in GIS world, they call that a one-dimensional object. So then we talk about an area or a boundary. The other big term that you're going to see in GIS is polygon. So area, polygon, boundary, those are all interchangeable or synonymous terms. And that's called a two-dimensional object. And then we have the volumetric data, which I refer to as a three. Some GISs don't really handle volumetric very well yet. So a lot of them are just going to be related to these kind of things. Now, of course, most of the surveying types of softwares that you're using, so if you're using Carlson or something like that, it handles all of this quite well, including volumetric data. Okay, so this would all fall under the concept of spatial data, and this is dealing with what we call the spatial dimensions, 0, 1, 2, 3 dimension. Okay. Any questions? Okay, then we get to this type of data, which we call non-spatial data. Good term for that, or the term that you will hear very often used in the GIS world or the spatial data world, is attribute data. So most of what surveyors are engaged in, we do a little bit of both, actually. This is primarily what we do. We do point location, length location, area location, and some volume. Now, we do some of this as well, because this is important. So basically, this is the information that is descriptive, that tells you about something, but it doesn't give you location. So it's strictly non-locational data. Okay, it's non-location based data. It is linked to spatial data if it's going to have any validity. Now, if you don't have it linked to spatial data, then it really doesn't have a lot of power. Okay, so we somehow have to link that. So one of the ways, for instance, you guys do that, you go out, you take and shoot a point, and your data collector gives it an XYZ, and it'll come back and ask you for a description. So when you give it a description, like a 12-inch maple tree, or a storm sewer, or a manhole, or whatever, you are giving it at that point attribute data or non-spatial data. And we all know that if we're dealing with mapping, if we go out and collect a whole lot of points, we've got great spatial data, but if it doesn't have any attribute data on it, it's worthless. If it's just 0.1, 2, 3, 4, 5, 6, I don't know what I've got. And so I can't do anything with it. So these two things have to be linked. And if they're not, this that doesn't have any spatial data with it is really worthless, but really spatial data that doesn't have any description can be worthless as well. All right, so we can say that non-spatial data knows what something is. So where spatial data knows where something is, non-spatial data knows what something is. Okay, so here's an example of a property. If you have a property, a polygon of some kind out there, you can have the boundary location, you know, the bearings and the distance that go around this thing. That's your spatial data. But then you're going to have things that you attach to this, like the owner's name, the value of that property, the zoning that it falls under, the land use type, okay, those kind of things, right? So again, keep those in mind. We're going to be talking about that a lot over time. You might be aware of those two things, but just remember, non-spatial is attribute, spatial data is location-based data. All right, so your book is showing you the concept of being able to use GIS or maybe remote sensing data that provides images or what we call snapshots of different time frames. And what we're looking at here, which is pretty interesting, this is actually Las Vegas, and it's showing you a time sequence, or what would refer to as, that's called a temporal sequence of timing of images from 1972 up to 2000. And very interesting to see what you're looking at is the land use pattern. And of course, this, I'm pretty much a desert out here. And it's pretty artificial city actually, but you can notice that in 72, the size of it, and notice how it's spread and the pattern how it's spread and which direction it's spread. That's also interesting. So you notice that the spread has pretty much been in this direction, and this direction a little bit, this direction. And if you look at that, probably the reason most of the spread has gone this way, it looks like this is pretty fairly flat over here, where we've got like somewhat of a mountainous area or something going on here. So you can see the spread tended to go that way, okay? And you can see what this looks like by 2000, and I'm sure it's even bigger today. And that, like I said, it's completely an artificial area, because without water, this place would not exist. And that's true with a lot of the West right now. They're experiencing water shortages. And at some point, we'll probably hit the wall on the growth on this place, because the water will be exceeded. And that's going to be true with a lot of the West. But this is kind of neat, showing you the temporal sequence of what's going on here. Okay, so another good source of data, and some of you guys may or may not be aware of this, is what's called the national map. So there's national level spatial data. This is maintained by the U.S. Geological Survey, the USGS. It's just distributed, it's free. You can go into the national map viewer. You can then go in and gather the data that you want and download this data and use it. So it's all free. Now it's not at a very good level for doing some of the things that we might want to do, some of the planning purposes, but for large scale stuff, or large area stuff, I should say, it's very good. So what you do is when you go to the national map, and this is one of the things I would encourage you. He's got this as a little aside in the book. If you go out there, it's pretty interesting. You just actually can just type in the nationalmap.gov and it'll pop right up. But it's an online database and data viewer that gives you downloadable geodata sets. And you can go out and get multiple layers. And so some of the major layers that you can get would be things like national elevation data sets. Hydrography, another name for that would be your water. So that would be like water courses, rivers, lakes, that kind of information. You have transportation type information that you can download, and you got land cover data. And you can do all of these different layers, or you can just do some of them. I definitely encourage you to do this because it's really neat, and it's all free. And if you have a GIS, you can actually take this stuff and then get it into the format that you want to use it in and download it into it. So that's pretty awesome. This is what the viewer, I think this picture might be a little old. It looks pretty similar to this, but it's a little different yet. But the viewer's real friendly. You can kind of just zoom around in that. So if I zoom in on this area, it kind of clips that as you get into it. And then you can go in and tell it what layers you're interested in. And then you create a cart, and then you just export that information out. So
Yeah, it looks like any county GIS interface. I just pulled it up.
yeah, it does, Ben, and it's really easy to use. And then you can just go in and say, okay, I want this layer, this layer, this layer. You take it over into your cart, and then you just download it. By the way, besides the national government that has this kind of stuff, a lot of the states do, and so do a lot of the counties. Now, some counties make you pay for data, some don't. Some states allow you to get it for free. So there is a lot of free data out there. But it's like anything else. You got to buyer beware. You got to make sure what you're getting, how you're getting it. And when you toss these data sets together, they don't always fit right. So you got to be kind of cognizant of all of that. But there's some really, really good free data when you get into this. But the national map is really very interesting to check out. So as I said, if you have a chance, check it out. Okay, so let's take a look at, we want to link this kind of back to geography a little bit. Because like I said, this author, he is a geography person. And so he kind of brings it back full circle with this. So one of the things about geography would be defined as the study of the Earth's surface as a space within which human populations live. So really, geography is looking at how humans really kind of interact with the Earth. So that's always been a big thing. And geography has a long history. So it probably even really it really predates a lot of obviously the geospatial type of stuff that we're talking about, but a lot of other disciplines too. So it goes back a long way. And geography kind of deals with not just where things are, but kind of why things are where they are. And of course, that would get into other things like anthropology and other issues as well. But it always has that long historical concept of dealing with that. So not just where things are, but why they're where they are. And so geography definitely deals with spatial characteristics of the Earth. So spatial characteristics, we're looking at things like mountain ranges and canyons and rivers, those kind of things, the topographic kind of things, more or less, and spatial relationships of the earth. So how things are related to this, so how a mountain range is related to, say, where the plain is, those kind of things. And the interactions of people and features on the earth. So these are three kind of areas that have always been part of that study. And geospatial technology certainly is part of this geography. And as a matter of fact, if you looked at a particular geography curriculum at most colleges or most universities, and for instance, the University of Cincinnati, you're going to see courses that involve geographic information system, remote sensing. They're now looking at probably GPS and data collection as well. In fact, if you wanted to get, let's say, an advanced degree in geographic information systems, which you could get like a master's and PhD at some universities, they don't have anything like that at the University of Cincinnati. What you do is you get a master's in geography, but it'll have a kind of a concentration in GIS. Although if you go to, say, like Penn State, you can actually get a master's in GIS. So this is a strong tie in almost any geography department in any university, probably worldwide, is going to be strong on GIS. It's going to be strong on remote sensing anymore. Because again, these are huge tools that these guys are using in terms of that. Okay, so there's other developments that have happened recently with allowing kind of non-professionals to get involved in this, because we have such available tools now to the public. You guys are all aware of this. And it's so easy to do certain things. We can utilize these to do things. And so one of the things they've got is this concept of VGI, this volunteer geographic information concept. And this was a term that was developed by Michael Goodchild, who, if his name is a big name in the GIS world, he was one of the original teachers and original people that got involved in that. But it's a term used to describe user-generated geographic or geospatial content and data. So what people do now is they go out and they can gather their own data, and then they can bring it into these GIS systems, and it's kind of like what they call crowdsourcing, or sometimes it's called citizen scientists, where people are creating their own data sets, their own databases that everybody can use, okay? It's kind of like a Wikipedia kind of thing, more or less. So we have that concept of a wiki, which is a database available for everyone to use and or edit. So we're seeing this more and more, and there's a couple, let's see if I don't have those listed. Yeah, there's a couple of those out there. One of these is this guy's called OpenStreetMap. So this is open source data. It's open source code also. So people can go in here and really edit things. They can put things in here, add this information. There's also open source GIS, is like QGIS that I talked about. That's an open source. So you can actually get the source code for that. You can write your own little applications, and then you can put that back up on their website, and then it becomes freely available to everybody. So this is a big thing, this concept of citizens mapping things and those things. The concept of citizen science has taken off big time in a lot of disciplines, and particularly in the biological world. Things that people will go out and they can actually identify birds or plants or whatever, and then put those into maps and make that available to kind of everybody. So we're seeing this more and more and more, particularly things like driving that or your social medias, those kind of things. All right, let's look at geolocation. So geolocation is the technique of determining where something is in the world. So what you're doing when you geolocate something, you're taking something that has absolutely no location or no reference to the face of the earth, and you are giving it now, or you're tying it down to the earth. So this is a very, very important concept, because without something being geolocated, it's a problem. So here's a good example that you guys could probably follow. You can go out and survey someone's property, right? We go out and let's say we find iron pins at every corner. So we can write the descriptions, the bearings on those and the distances and on that, and we have this nice polygon. But that doesn't necessarily mean it's geolocated. So in other words, if we don't know a specific location of each pin in terms of either a latitude and a longitude or possibly a state plane coordinate, that polygon is just floating as far as anybody else is concerned. So we know where it is physically on the earth because we can go out and find that pin. But in order for it to be tied into something, it has to be tied into something that was typically called a datum, and then that's given a good coordinate, a good value. And that's the process of geolocating. So a lot of times when we do boundary surveys, we don't necessarily geolocate it, okay? We write the description, maybe tie it into another, something. Everybody really knows where it is, but it's not necessarily geolocated. Now, a lot of municipalities now require those things to be displayed in state plane coordinates, or they may require latitude, longitude, those kind of things. So we're seeing more of that. But again, that's the process of geolocation. So things that you can use for geolocating: smartphones, tablets, laptops, desktop, they can all determine a current location using that geolocation process. So you can provide a coordinate through either an IP address or a Wi-Fi connection or cell tower connections. Now, those aren't going to necessarily be as good. They're going to be a little bit fuzzier than other types of locations, but you can get a pretty good location. So like right now, I can open up my cell phone and I can go to Google Maps and I can actually see where I am sitting. Now it's not going to tell me exactly where it is, but it's geolocating me. And it's probably based on either my Wi-Fi connection or it could be my GPS chip in my phone. So that's a kind of a cool thing.
Jim, do you think at some point that they will try to geolocate property lines and have legal standing?
Well, I think that's coming. I think that some people have actually tried to do that, and there's a big argument about that in coordinates kind of thing, because of course, as surveyors, we know that the coordinate isn't necessarily the important thing when you're doing a boundary, right? You have to find control. You have to find existing monuments, and certain monuments hold over other monuments. So there's debate about some of that going on. But
I do a lot of work in.
Go ahead.
I do a lot of work in Nashville.
That was a little. Can you say that again, Donald?
I work a lot in Nashville, and they require.
I can't hear you. It's breaking up.
I work a lot in Nashville, and they require state plane on every plat.
I heard
So they require state plane on every plat in Nashville.
Okay, all right. So they're doing that in certain areas. That's true. And I think you're probably going to see that more and more and more. Okay. So, but again, there is that. You got to be careful with that because the coordinate. Are you going to say that the coordinate has more validity than the point, right? So you guys that do surveying, there's importance of conflicting elements kind of thing you go through. What's at the bottom of that heat? Does anybody know? Coordinates are at the bottom.
Oh yeah, at the bottom of the rules of construction.
Exactly. So whether that will change over time, we'll see.
Our municipalities are requiring that just so they can place the parcels in their GIS easier, aren't they?
Precisely. But here's the thing that happens with that is a normal person that doesn't know anything about this can go out there and get those coordinates, right? And they download those into their handheld GPS and they think they can go out and survey. That's not the same thing, right?
Sure.
So we have to look at that, and I think that's going to be a debate that's coming. And I'm not debating it one way or the other, but we have to look at what's going on there. As coordinates get better, and they are getting better, that's for sure. We're going to see that. That may be to the point at some point when that happens, the coordinate will be higher up on the list. Yeah. So, okay, good debate. A geolocation can be accomplished through a process called W3C geolocation API. So this allows programmers to write programs that can tap into this. They can obtain that information from either computers or mobile phone type devices, and then they can write programs that will create that kind of stuff. So that's a pretty neat little process. I have a really cool app. I don't, if anybody's may have seen it. I like to hike a lot, and there's a little free app you can get called All Trails. And All Trails is awesome because if I'm in an area, let's say I'm out over in East Fork Lake, and there's trails over there that somebody has mapped, and they have produced this map and All Trails, I can go out and use their map, turn my phone on, and it shows my location on that trail. So it shows me whether I'm on the trail or not. And this is a completely free software, and it's user driven. So people are utilizing these geolocation concepts. They're mapping it, they upload it to All Trails, and then All Trails will review it and they'll accept it. And then it's available to other people. And it's actually really awesome because not only does it show you the trail, but it also has a profile. So it shows you what the ground is doing as well throughout this. And it's all linked to a topographic map. So it's a really, really awesome feature. And I've been really utilizing that a lot. It's kind of fun. So if you get a chance, it's a free download. It's called All Trails. You guys want to check it out. And they do have a professional version. I think you can pay like so much per month, and you get all these little bells and whistles. But trust me, for what you're getting out of it, you don't need it. It actually works very well. So some of the other devices that we talk about a process of geotagging data. And what that means is you are providing a location to that data. So an example, you guys all probably know this on your phone. You can geotag your photos or your Facebook twists or Twitter tweets, those kind of things. But you can, if you geotag your photos, then you can actually upload those to other programs, and it'll put that photo in the location. Now you have to have that turned on. So I do a lot of times where I'll take pictures. I don't have them geotagged because I don't care, but a lot of times I will. This is an example of a Twitter thing. This map was taken after the massacre that occurred in France in 2015 on that Charlie Hebdo magazine. And what this was showing you is this was support for that group, not the group that did the massacre, but kind of as in reference to the people that got massacred. And you can see this is showing you all the Twitter locations where people did this. And of course, that it happened in France, and we're seeing the majority of this was in the Europe and Eurasian area, but we're seeing a lot in North America. So these were all Twitter locations based on that. All right. So last thing we're going to talk about today, and then we'll be done and let you guys get going, is Google Earth, because we're going to be dealing with this, using this in the software that we're going to be getting into. So the first thing is talking about what Google Earth is. And we'll be utilizing that. And I'm sure everybody has used it, but actually, when you get to go through this little exercise that he goes through, it's actually pretty neat because a lot of people don't know that it'll do some of the stuff that it'll do. So we'll see. But basically, it's instead of a map, it's what you call a virtual globe. So it is a true three-dimensional kind of concept. It provides for the user a 3D interactive view of the Earth, and so you can rotate it and move it and zoom in and out, those kind of things. It was released in 2005. It was originally written by a group called Keyhole, I believe, and Google ended up buying them out, and then made it freely available software for download. It does handle vast amounts of geospatial data, so you really have to have a real link into it, otherwise it's pretty slow. It is basically using two types of imagery, but that's static. So this imagery is not real time, and some people think that it's a real time kind of thing. and which it's not, but it's static, and you can choose the available data sets by year. And they did at one time do constant updates. I believe they don't update this anymore. This was, I think, this is an older picture. I think the interface looks a little different, but basically there's your map view, and then you have what you can do as a search, place names and layers box. It's slightly different. This is an older version. So yeah, that's from 2012. So some of the applications that you get into with Google Earth, viewing the entire globe, and it's based on two types of imagery, satellite imagery and aerial photography, or aerial photos, so they put those two things together. One of the neat things they do is that 3D navigation thing. They've got some pretty cool stuff in that. You can do some fly-throughs and stuff with it. You can zoom from orbit to street address, or do some type of global measurements. So we're going to see how some of those things work. And it is kind of neat because it'll give you, I believe, ellipsoid distance or a straight shot distance kind of thing. Allows you the ability to examine multiple layers of spatial data. And this is probably a more realistic view, but what you're seeing here is a 3D view. And obviously these models have been built by somebody, and some of them look pretty crude actually. You'll see if you've used that, but they're getting better with it. And so the imagery is fixed, so it's not in real time. That's the one thing to understand, and it's definitely not current. It does allow you to, and a lot of people don't know this, you can actually use past images. So for instance, imagery or house may be available in different years. The other house I used to live at, it was a newer house, and when I did Google Earth initially, the house was basically just a foundation, but you could actually go back and look at the foundation, then you could look at it under roof, so it was kind of interesting to be able to do that. Okay, so that kind of concludes what we're going to be getting into today. Like I said, this lecture was a pretty simple lecture, just a lot of good introductory information. So let's see, let me close that out. Let me see if anybody has any questions. And otherwise, we'll be done. Anybody have any questions? Anything they want to discuss?
Jim, are you just going to send out a link every week? Is that how that's going to work via email?
It's exactly how it's going to work. And did that work okay for everybody?
Yes.
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 Yep.
Because I can do that, or I could probably put a link as an announcement, but I think it's probably better because I have to set up the meeting and then I'll just send the link. So if that works, and I'll just do that. Just make sure you look in your email. And probably since, you know, I'm basically just running from place to place, it'll probably be about 3:25 again. Okay. That way, or 3:20. So I'll be there before 3:30 for sure. I don't think I'll have any problems meeting that criteria. Okay.
Okay.
All right.
And we have a lab this Thursday at 3.
Correct. And so we'll keep the labs at 3 o'clock on the face-to-face section. And again, so that way you guys can get in and get out, because I have a night class after your class. I have a really busy schedule. So yeah, so I would that's what we'll do that. Okay. So 3:30 for the lecture, 3 o'clock for the lab. And also I will tend to do the quizzes and the tests on that Thursday time frame as well. Okay. And so we'll do it over that situation same way.
Will there be a quiz this Thursday?
Probably will, but it'll be based on this simple first chapter stuff. Okay.
And is that open book?
Yes, I use open book for the test and for the quizzes. Correct. Okay.
Are the quizzes something that I'm going to have to be present for?
No. What I will do,
Okay.
Ron, is I will be able to send you a document. I'll either do it. I haven't figured out how I'm going to do it with you yet, but I may put it on Blackboard, and you just take it
Okay.
to Blackboard. What I've done, like on tests, is I'll just give you a document, you'll download it, take the quiz, and you just send me, you have to send me back, but you have like a time frame that you have to do it within. Okay, so in other words, once you start the test, it's like or the quiz, it's like a 30-minute time frame. So what I'll usually do is just have you like key in the answers in Blackboard. The quizzes are going to be simple, 5 to 10 questions that are multiple choice. Okay. All right. Anybody else questions? Okay, I will go ahead and I'm going to stop the share. When I do that, it's going to go ahead and I've got to format this lecture. So what I will do then is as soon as that lecture becomes available, I'll put that up on my Blackboard site, and it'll give you a link to YouTube. Okay.
Thanks, Jim.
All right.
Okay.
Well, guys, it's been good so far. Hopefully we'll get into some good stuff. I know it's a little hard for me because I don't get a lot of feedback from you guys. So hopefully I'm keeping it vibrant and a good thing for you. Okay. So, but we'll be able to talk a little bit more when we get into the face-to-face piece. Okay.
Alrighty.
All right.
All right.
Great.
Thank you.
So, all right. We'll
See you Thursday.
see you Thursday, right? And then Ryan, I'll be sending you stuff, or I'll have that stuff out there for you.
Excellent. If you need to give me a ring or a call, just call me on my cell phone. We can talk about it.
Okay. Perfect. That works great. That works great for me. Okay. All right.
Thanks.
All right.
All right. All right.
Thanks,
See you
Jim.
guys.
Bye
See ya.
now.
Bye.